Alright guys, we're going to look at the next video, which is on stoichiometry. So we've looked at balancing chemical equations, and we should feel fairly comfortable with that at this point in time, considering you did it last year and you just watched the video on it. Stoichiometry ties into balancing chemical equations because we require balanced chemical equations to be able to do stoichiometry. Remember, stoichiometry is looking at the quantitative values or relationships between both reactants and the products. And we can go back and forth between reactants, back and forth between products, or between reactants and products. There's no rhyme or reason for where we have to start and where we have to end. I know some people get into their heads that we have to start at a reactant and we have to go to a product. Not necessarily. We can start at products, go back to reactants, start at reactants, go to products, start at reactants, go to reactants, start at products, go to products, etc. So it just kind of depends on the problem we're given and using the mole ratios from there. Now, stoichiometry is all based off the law of conservation of matter, so just kind of keep that in mind as we're going through. Now, we need three things while we're doing the stoichiometric equations, or problems. We need a balanced chemical equation, which we should be able to do. We should be able to convert moles to grams using molar mass values, and we should be able to use molar ratios from a balanced chemical equation. So, with that in mind, let's say we are doing a moles to gram problem, just reviewing how to use molar mass. Let's say I have 35.2 grams H2O. Okay, so remember, I'm going to draw my train tracks around that. Okay. I know water has a molar mass of 18 grams. Okay, because remember, one hydrogen has a mass of 1.01 basically, and oxygen has a mass of 16.0. So add them together, 2 hydrogens, so 16 plus 2 is 18. And technically it should be 18.0, but that's okay. And that is per 1 mole H2O. So from there we do our math of 35.2 divided by 18, put that into proper sig figs, and we go from there. And just so you have an idea what this would look like, we should get, with 3 proper sig figs from our given, we should get 1.96 moles H2O. So if you just want to make sure you can type that in your calculator and are able to do that, that is great. Now, mole ratios, we know how to balance a chemical equation. Our coefficients, which is the big numbers out in front, are where we get our mole ratios from. So our ratios would be 2 hydrogens to 1 oxygen, 2 hydrogens to 2 waters, and then 1 oxygen to 2 water. So any of those are considered a mole ratio. Okay, so let's just look at a full-blown stoichiometry problem. If we start with 54 grams of hydrogen, how many grams of water are produced? So we take it one step at a time. We start with our given of 54 grams of H2. We know we have a molar mass of hydrogen of 2 grams, or 2.0 to be a little bit more precise, and that's per 1 mole of H2. Now, our mole ratio, this middle step, watch your units. Make sure that your hydrogen is matched up with your hydrogen. And of course, we get our mole ratio from our balanced chemical equation. So there's 2 moles of hydrogen to 2 moles of water. And then, of course, our last step is to get back into grams. So 1 mole of water has an 18.0 gram mole value. So we calculate it from there. So we have 54 divided by 2 times 2 divided by 2, and then again times 18. So with 2 proper sig figs, this should be about 490 grams H2O. Okay, let's look at another one. Okay, let's say we have 13 grams of iron. How many grams of oxygen are needed to react? So first off, we have to balance. We have 2 things of iron, 3 things of oxygen. Okay, this goes back to balancing oxygens first. Notice we have even here, odd here. So I'm going to put a 2 in front of here to balance out my oxygens. That gives me 6 oxygens. I can put a 3 in front of here to get 6 oxygens. 2 irons times 2 is 4. So throw a 4 out in front here, and that gives me my 4 irons. I'm then going to go through and do each step. So 13 grams, Fe. Okay, draw my train tracks. Okay, well, iron has a molar mass of 55.8, so we're going to put that down here. Per 1 mole. We're then going to grab our mole ratio of iron to oxygen. Well, iron is 4, and I'm going to put that down at the bottom so my units match, Fe to Fe, to 3 moles of oxygen. And again, notice we're staying on the reactant side. We're not even touching the product side here. Okay, and the last step is to go to grams. So 1 mole of O2 is how many grams? Well, it's 16 grams to begin with, but it's O2, it's a diatomic, so remember that. So it's actually 32.0 grams O2. So now we go through and calculate this. 13 divided by 55.8 times 3 divided by 4, and then times 32. Okay, so again, with proper sig figs of 2, because the 13 is just 2, this should be 5.6 grams O2. Okay, and one more for safe measure, and then we'll look at limiting reactants. So again, make sure you balance the equation. 2 hydrogens, 1 hydrogen. Throw a 2 out in front. That gives me 2 chlorines, 2 chlorines. It's already balanced and ready to go. If 456 grams of calcium chloride are produced, how many grams of hydrochloric acid reacted? So 456 grams CaCl2. Notice here we're starting with a product. Okay, so we draw our lines, we go down. We need the molar mass of calcium, or calcium chloride, I should say. Calcium is 40.1 plus 2 chlorines, which is 35.5, times 2. So our molar mass here is 111.1. Okay, and that's per 1 mole CaCl2. We do our mole ratio of CaCl2 to hydrochloric acid. Well, there's 1 mole of CaCl2, because there's a 1 here that we just don't see, to 2 moles of HCl. And then our last step is to go into grams of HCl. So for every 1 mole of HCl, we end up having 36.5 grams HCl. So now we do our math. 456 divided by 111.1 times 2, and then times 36.5. So with proper sig figs of 3, and this one actually does not work out to proper sig figs, but it's roughly about 300 grams HCl. You'd have to put that in scientific notation to get the amount of sig figs you need. But that is it for now. We'll look at limiting reactants in just a minute.